Hello everybody, we are from Group 2. Our group members are Nur Aliyah binti Abdul Aziz, Anis Zulaika binti Roslan, and Nur Fatma binti Ujang. In this video, we are going to explain about atomic absorption spectroscopy. Introduction. Atomic absorption spectroscopy is a quantitative method of analysis of any kind of sample that is applicable to many metals and a few of non-metals.
Atomic absorption spectroscopy is a very common technique for detecting metals and metalloids in sample. It is also very reliable and easy to use. It can analyze over 62 elements, and also it can measure the concentration of metals in the sample.
These are the examples of the detectable elements for the atomic absorption spectroscopy. History. This technique was discovered in 1955 by Alan Walsh in Australia. The first commercial atomic spectrometer was discovered in 1959. Principle. Atomized elements each absorb energy of a wavelength that is particular to that element. It uses a hollow cathode lamp which emits light of a wavelength that is particular to each element. Elements within a solution are heated in a flame or electrically and determined using the degree of absorption that will vary with its concentration.
Configuration for absorption measurement. The source radiation of the selected wavelength is sent through the sample, and the transmitted radiation is measured by the detector signal processing readout unit.
Instrumentation. The atomic absorption spectroscopy consists of several instruments, which are the hollow cathode lamp, detector, monochromator, atomizer, and nebulizer.
Hollow cathode lamp is the most common radiation source in atomic absorption spectroscopy. It contains a tungsten anode and a hollow cylindrical cathode made of the element to be determined. These are sealed in a glass tube filled with an inert gas. Each element has its own unique lamp, which must be used for that analysis.
Monochromator. Monochromator is used to separate out all of thousands of lines. Also, it is used to select the specific wavelength of light which is absorbed by the sample and to exclude other wavelengths. Diffraction grating is the process by which a beam of light or other systems of waves is spread out as a result of passing through a narrow aperture or across an edge, typically accompanied by interference between the waveforms produced. Nebulizer. The liquid samples were sucked at controlled rate. A fine aerosol spray was created for introduction into flame. The aerosol, fuel, and oxidant were mixed thoroughly for introduction into flame. Atomizer. Atomizer is the separation of particles into individual molecules and breaking molecules into atoms. There are two types of atomizers, which are flame atomizer and graphite furnace atomizer. Flame atomization. In this method, flame is used to atomize the sample. When heated, the sample is broken into its atoms.
Sample is introduced via aspiration. The nebulizer controls a sample flow and produces a mist. The mixing chamber assures the sample mixed with the oxidant and fuel prior to enter into the flame. The flame forms and the atomization occurs.
Flame structure. In primary combustion zone, the bioluminescence is due to C2 and CH and the thermal equilibrium is not reached. In internal region, there is high concentration of free atoms and it is suitably used for spectroscopy. In secondary combustion zone, the element is converted to oxides and disperse the sample to the air.
The advantages of flame AAS are low maintenance cost required, relatively short measurement time, simple and convenient. For the disadvantages, it can only analyze solution, sensitivity limitation, higher initial sample volumes required, poor efficiency, and short residence time of analyzing optical path.
Graphite furnace atomizer. In this method, samples are placed in a carbon tube which is heated electrically. However, we can simply heat the sample to atomization temperatures or the sample will splatter. We use a temperature program to ensure the reproducible atomization.
A three-stage program is the most common. Firstly, drying, a fixed temperature and time used to remove solvent. Secondly, etching, a second temperature or time used to decompose your matrix. Thirdly is atomization, a rapid increase to 2000 until 3000 degrees Celsius for just a few seconds when you collect your data.
Advantages of graphite furnace AAS are enhanced sensitivity, small sample size, direct analysis of solid sample, little sample preparation is needed, and more efficient. The disadvantages are limited analytical range, low sample throughput, requires experienced operator, and very expensive. Detector. The light selected by the monochromator is directed onto a detector that is typically a photomultiplier tube. It converts the light signal into an electrical signal proportional to the light intensity. Readout device. The signal could be displayed for readout in the readout device. The examples of readout devices are digital voltmeter, simple galvanometer, potentiometer, and computer. Demonstration of flame atomic absorption spectroscopy. This is the gas that feeds the flame. These are the lamps that provide the source of radiation. The lamp is specific to the analyte. The analyte is taken into the flame by this capillary tube. Data collection is performed by software installed on a computer. This demonstration will use a sample of copper. First, start by cleaning the sample capillary with a chemical wipe. Then, insert it back to be aerosolized, mixed with gases and released into the flame. The flame turns a green color that is distinctive of copper. Waste is then siphoned off into a collection bucket. The data is then sent to the computer for analysis.
Application. Atomic absorption spectroscopy can be used to determine the small metals such as lead, mercury, calcium, and magnesium in several samples from several sources. First sources is from environmental, which come from ocean water, river and stream water, also wastewater. Second sources is from metal, semiconductor, and ceramic, which is from metals, ore, clay, and ceramic. Thirdly is industry. The sample could be from oil, catalysis, synthetic product, and food. Lastly is pharmaceutical, which is come from blood, biological organism, plants, and drug.
Okay, that's all from us. Thank you and
Selamat Hari Raya!